Welcome everyone. This is Dr. A. Sumarani, Assistant Professor, Department of IT, Erode Sengundar Engineering College, Perundurai. In this presentation, we are going to see about basics of C programming. Introduction to C. C was developed by Dennis Ritchie at Bell Laboratory in 1972, and it is an upgraded version of languages like B and BCPL. Features of C. C is a structured programming language. It uses top-down approach. It is highly portable. It is a middle-level language, and it is a case-sensitive language, and it is free from any languages. These are the features of C. And structure of C programming. It starts with document section, preprocessor section, and definition section. And after that, main will start. In main section, it starts with declaration part and proceeded with the execution part. And after the main get closed, subprogram section is continued, which consists of the body of the subprogram. How we will execute the C program? First, you want to enter the C editor and type the program, and after that it is saved by using F2 key or by using the menu File Save. This file is saved by using the extension .c. And for compiling, you can either go with Alt F9 key or with the tab Compile. And for running a program, you can go with Control F9 key or the tab Run. This is the execution of C program. Whereas in Unix also C program can be executed. For that, you want to enter the program in VI editor. The file is saved by using the extension .c with the help of the command :wq. And for the compilation, the syntax followed is cc filename.c or gcc filename.c. Then for running a program, you want to use a.out. This is the execution of C program in Unix. We'll see a basic things that is used in C programming. First is identifiers. Identifiers are names given to various program elements such as functions, arrays, and etc. Example, here int average marks. Here average and marks are declared with their data type int. Here average and marks are called as the user defined identifiers. It was defined by the user. Rules for naming identifier. For the identifier, first character must be alphabetic or underscore. It must consist of alphabetic characters, digits, or underscores. Only 31 characters, first 31 characters of the identifiers are significant and others are recognized by the compiler. Keywords and reserved words cannot be used, such as main, include, printf, scanf. These are the keyword statements that cannot be used for naming the identifier. No spaces are allowed between the identifiers. Since C is a case sensitive, the identifier should be named with a clear case sensitive. That is, if you give the name as a capital letter, that should be given everywhere, that should be called or given everywhere in a capital letter only. For example, capital MY underscore ID is not equivalent to small my underscore ID. And this is the valid and invalid names example. Here the valid names are A1 student name. So in this way, true, false. In this way, you can able to give valid names, and invalid names are $sum. Here you should not give like that because dollar is a illegal naming conventions. And two names, that means this is not a method for giving identifier name, because in identifier the rules is it should start only with the character. Here we are starting with a number, so it does not does not be considered as an identifier. Student number, here there is a space between student and number, so it is not considered as an identifier. And int, it is a reserved word, so this cannot be used as an identifier. These are some of the examples of valid and invalid names. Then comes variable. Variable is an identifier that is used to represent some specified type of information. Example, a is equal to 6. Here a is a variable. Keyword. It is a reserved word that cannot be used for anything else. Example for the keywords are int, double, auto, extend, then long, switch, case. These are the keywords which cannot be used for declaring as identifier, and so on. So, constants. Constant is an entity that does not change the value during the execution. Once you declare a constant value, that is not changed during the execution. Constant is divided into two, that is numeric constants and character constants. Numeric constant may be an integer constant or real constant, and character constant is a single character constant or string constant. Here is a numeric constant, that is integer constant. It is formed using a sequence of digits. For example, if it is a decimal, that is formed using 0 to 9 number, and if it is octal, it is from 0 to 7. If it is hexadecimal, it is from 0 to 9 and A to F. And rules for defining the integer constants are: it must have at least one digit. Decimal points are not allowed inside an integer constant. There should not be any space or commas allowed. It can be a positive number or a negative number. A numeric constant, there is another type called as real constant. This real constant is formed using a sequence of digits, but it contains decimal point, whereas an integer constant, it does not contain decimal points, whereas a numeric constant, it will allow the use of decimal points. Example, we can take length, height, price, distance. These are measured in real numbers. For example, 4.5, 7.2. These are the numeric constants. Character constants. Single character constant is a single character where it is represented with single digit or single special symbols that should be always enclosed in a single quotes. Here see an example. Single quotes, within single quotes X, within single quotes 9, within single quotes underscore. And this is an example for single character constant. It should be included within a single quotes, and it can be represented only with a single digit. String constant. String constants are sequence of characters that is enclosed within a double quotes. Here, hello world. This is a collection of strings or character which is enclosed within the double quotes. 17. It can accept 2 digit. So this is a string constant. And data type. A data type is a classification of identifying one or more types of data, such as real value, integer or boolean, that determines the possible value of that particular type. The standard data types used in C are void, int, character and float. These are the keywords for the data types also. Void, for integer you will be specifying int, for character CHAR, and for float it is float. Integer, it is a number without fraction part. This occupies 2 bytes for memory, and the control or format string for integer is %d. C supports 3 different sizes of integer data type. One is short int and long int. Then comes floating point. Floating point is a type of number with a fraction type. It will consist of fraction. Example, 16.12, 20.2. This is a fraction type. This is floating point. And this floating point occupies 4 bytes of data. And the format string used for floating point is %f. C has, as like integer, C has 3 different sizes of floating point data type: double, float and long double. Then character. Character are generally stored using 8 bits, that is 1 byte of internal storage. The format string used is %C. For example, consider a capital A character has the ASCII value 65 when it is represented in decimal, and the same 65 is represented by binary using this number. And for the small a, the ASCII code is 97, which is in decimal, whereas in binary it is represented by using 11000001. This is the character and the ASCII code for the particular character. It occupies 1 byte of storage. Void. Void type has no values or no operations. It sets the value and operations as empty. And these are the data types used in C. The data types for character, it occupies 1 byte and the range is from 128 to 127. The format string used is %C. For unsigned character, the same 1 byte is used in memory and the range is from 0 to 255. Control string or format string is %C. Short int or integer occupies 2 bytes and the range is this, and the format string is %I or %D. Unsigned integer also occupies 2 bytes. The range is from 0 to 65,535 and the format string used is %U. Long integer occupies 4 bytes of data and the range is given here, and the format string is %LD. Unsigned long occupies 4 bytes and the range is given. Format string is %LU. Float occupies 4 bytes and the range is given here, and the format string is %F or %D. Double occupies 8 bytes of data and the range is given here, and the format string used here is %LF. Long double occupies 10 bytes. The range is given here. The format string for long double is %LF. Then variable declaration. To create a variable, we must specify the type. For example, here rate, I, J, name are the variables. Here we are going to specify the type of these variables. Float rate. The rate is a float type. I and J are of integer type and the name is a character type. Then types of operator. There are many types of operators in C. Some of them are arithmetic operator, relational operator, logical operator, assignment operator, increment or decrement operator, that is unary only, bitwise operator and conditional operator. Arithmetic operator, it is used to perform arithmetic operations like addition, subtraction, etc. The arithmetic operators are plus, minus, star and slash. A sample program for performing arithmetic operation is given here. Specifically, we are performing addition, that is by using a plus symbol. Always the C program will start with the header file #include stdio.h. Then conio.h, console input output header file is also used. Here these are the two header files. Then you want to declare a variable. Okay, I am declaring an integer variable and the value assigned to b is 23. Since we are declaring the variable before a main function, that is considered to be as the global declaration, because since it is declared before the main function, it can be used in anywhere of a program. Once if you declare the variable inside a main function, that is called as a local declaration, which means that that particular variable can be used only inside the main function. So after a main function, you are declaring a variable a and c, which is of same integer type. Then you are going to clear a screen by using a function clr_ser. Then by using scanf statement, we are getting the value of a by using &a symbol. So after getting the value of a, you are going to print the addition of a and b in the variable c. C is equal to a plus b. Here we are getting the a value by using scanf statement. For example, if you are getting 5, then the b value is taken. Since the b is declared globally, b value is taken from there. It is 23. So 5 plus 23, it is 28, that is stored in C. So when you print the C value by using printf statement, 28 value will be printed. Then get ch, closing the program. This is a sample program for performing addition of two numbers. Then division operator. For the division operator, when we perform division operator with different types of data type, what happens? That is what given in this table. When the division operation is done between integer and integer, the result is integer. An example here is given. When the operation is done between integer and real, the output is real. And for real and integer, it is real. And finally, when you perform on real and real, the output is also real. An example for these is given in the last part. Sample program for the division operation. Always the C program will start with a header file followed by a main function. Inside a main function, variables are declared which is of integer type. Here a is equal to 15 and b is equal to 2, and I am just declaring a C variable for storing a value. Then float variable is declared where d is equal to 4 and e. C is equal to a by b. Since it is both are integer, the output is also integer. And we are going to print the value of C by using printf statement. Then e is equal to a by d. A is an integer and d is a float type. So when you divide integer by float, the output is float. So we are getting the value of e in a printf statement. We are printing the value of e in the printf statement, and the output is given here. A divided by b, both integers, so the value is integer. A divided by d, integer slash float is equal to float. So the output is displayed in float. Then relational operator. Relational operator is used to compare two or more operands. Some of the relational operators are less than, greater than, less than or is equal to, greater than or is equal to, not equal to. The example given, 8 less than 11, 10 greater than 7. This is how you can perform relational operations. Sample program is given for relational operation. As like the previous program, we need to start with the header file, and at a main function, we are declaring the variables a, b and c as an integer type, and the relational operation is done for comparison. Here we are comparing a with b. If a is greater than b, we are going to print a is bigger. Else, if a is greater than b and the same a is greater than c, we are going to print a is biggest. Okay, and this comparison is logical. The previous one, a greater than b, is a relational operation. And this is the output. Since a is greater than b, the condition a is bigger is printed. Then a is compared with b, the condition is true, and a is greater than c. Both the condition are true. A is biggest is printed here. Then the logical operator. Logical operator is used to combine the result of two or more conditions. Some of the logical operators used are and, the specified symbol is given, or the symbol, not, the symbol is given. These are the logical operators. Example, a is greater than b 5 and b is greater than 3. This is one example. And I is greater than 9 or j is greater than 6. These are the examples of logical operator. The sample program is given for performing the logical operation. And after, start with a header file, and inside a main function, I am using the year. This program is to find whether the given year is leap or not. We are getting a year value by using printf statement and scanf statement. Ampersand year, we are going to get the year, and the year is compared or with the specified conditions, so that only we can able to find whether the particular year is leap or not. The condition is the year should be divided by 4, that should be equal to 0, and when the year is divisible by 100, it should not be equal to 0. When these two conditions are satisfied, that is a leap year. Or when the particular year is divided by 400, it should produce 0. Only when this condition is satisfied, we can say that particular year is a leap year. Here we are comparing these operations and printing the year is leap year. Else, if the above condition is not satisfied, we are printing it as a not leap year. This is what the output is specified. 2010. 2010 is not a leap year because when it is divisible by 4, it does not produce 0, and when it is divisible by 100, it's not is equal to 0. When it is divisible by 100, it is 0. Then comes assignment operator. It is used to assign a value or expressions to a variable. For example, a is equal to 6. Here we are assigning 6 to the variable, 6 value to a variable a. Whereas a is equal to b is, we are assigning the b value to a. A is equal to b plus c is, the b and c is added and the result is stored in a. This is an assignment operator. In assignment operator, there is a compound operator and nested operator. Compound operator is used to assign a value by means of this. See an example. A plus is equal to b, which means that a is equal to a plus b. This is an example for compound operator. Then nested operator. In nested operator, multiple assignments are done. Example, I is equal to, j is equal to, k is equal to 0. Here we are assigning 0 to all the 3 variables by using this format. This is called as multiple assignment. Sample program is given here. Header file. Then we are declaring b is equal to 10, which means this is a global declaration. Then inside a void main program, x is equal to 4 and y is equal to 6. X plus is equal to y is given, which is a compound operator. That means x is equal to x plus y. The sum of two numbers x. We are producing here. Sum of two values 10, but it is given as 8 here. So when you perform x plus y, it is 10. The output is 10. Increment and decrement operator. The increment operator has pre-increment or post-increment, and the decrement is also pre-decrement and post-decrement is done. Here pre-increment is pre-increment plus x is a pre-increment where it will increment the value and the value will be printed. Whereas in post increment, the x value is printed, the old value of x is printed and then x gets incremented. Same as for pre-decrement. In pre-decrement, the value of x is decremented and then it is printed. In post-decrement, the old value of x is printed and then the x gets decremented. This is unary increment and decrement operator. The sample program, main function, here declaring a is equal to 7. Post decrement is done a plus plus, which means that the value of a is printed and then it is incremented. So when you print the value, 7 is printed. See in the output, 7 is printed. Now the a gets incremented by 1, which is 8. Now the value of a is 8. And in second printf statement, we are going to pre-increment plus plus a. So a gets incremented and then printed. Since the value of a is 8, now it is incremented by 1, which is 9. The value is printed here. Now the a value is 9. Then in the third printf statement, decrement value minus minus A, which means that A gets decremented and then printed. So current value of A is 9, 9 minus 1 is 8. So 8 is displayed. And in the fourth statement post decrement, which means that A gets printed and then decremented. The old value of A is 8. 8 is printed. Now the A gets decremented by 1. Now the value of A is 7. So this is how pre-decrement and post-decrement can be done. Bitwise operator. Bitwise operator is used to manipulate data at a bit level. For example, A is equal to 5 and B is equal to 4, and this is the bitwise representation of 5, and this is for 4. When you perform A and B, the output is this. A or B, the output is this. When you perform AND operation, the truth table for A is when the value of A and B is 0, 0, the output is 0. When it is 0, 1, the output is 0. When it is 1, 0, the output is 0. When it is 1, 1, the output is 1, which means that when both the value of A and B is 1, the output is 1. When a particular value is 0 or both the value is 0, the output is 0. So this is how A and B operation is done. Whereas for OR, it is when a particular value is 1, the output is 1. That is for 0, 0 it is 0. For 0, 1 it is 1. For 1, 0 also it is 1. And for 1, 1 it is 1. So this is the A and OR operation is done. A or B operation is done. Sample program. Inside a main function, int x is equal to 5, y is equal to 4, and z is declared. Here z is equal to x and y. What we are going to do here is the 5 binary representation of x is written and y representation is written. When those two things are making an AND operation, the value produced is 4. Conditional or a ternary operator. It is used to check the condition and execute the statement depending upon the condition. Ternary operator. For example, C is equal to A greater than B question mark A colon B. This can be read as if A is greater than B, then A, else it is B. That means when A is greater than B, A value is printed. When A is not greater than B, B value is printed. That is what given in this sample program. Hash include stdio.h, conio.h. Inside a main function, int A is equal to 5 and B is equal to 8 and C is declared. Here you are going to print the value through the variable C. Here you are comparing, that is a conditional operator. A is greater than B, print A. If A is not greater than B, print B. That's what given here. See, when comparing A and B, what will be printed? A is greater than 8. No. Only A is less than B. So the value printed here is B. So the larger values, B value will be printed here. Then comes the special operator. Special operators are comma, size of operator and pointer operator. These are the special operator used in C. The operators are ampersand and star used for pointer. This is the sample program. Hash include header files, and inside a main function I am declaring a variable A, and when I print the size of the variable A, it will be printed as 2, since the variable occupies the 2 variable integer occupies 2 bytes of memory, it is printed as 2. Here to print the size of within bracket A is used. Expressions. An expression represents data items such as variable constants which are interconnected using operator. This is an example given for expression. Normal expression A plus B plus B. In C expression also same thing. A squared plus B squared expression can be expressed as A star A plus B star B. Operator precedence and associativity. The arithmetic expressions evaluated or carried out based upon the precedence and associativity. See, the first phase and second phase is considered. In the first phase, higher priority operators are evaluated, and in the second phase, lower priority operators are evaluated. The higher priority operators are star, slash and percentage, that is modulo. The lower priority operators are plus and minus. This is an example. 5 minus 20 slash 4 plus 3 star 3 minus 1. Here, normally slash has the higher precedence, so 20 bar 4 must be performed first. The value is 5. Then that is followed by star has a higher preference, so 3 star 3 is performed. The value is 9. This is the statement. 5 minus 5 plus 9 minus 1. After that, minus and plus is there. Both have the equal precedence. So you want to come from left to right. That is 5 minus 5 0 plus 9 minus 1. Then 0 plus 9 is 9 minus 1. The value is 8. Whereas when you consider for C, the operators are separated by using a bracket. So the same expression is written in this format. 5 minus within bracket 20 slash 4 plus 3 star should be separated with bracket star within bracket 3 minus 1. So when you perform operator precedence, first slash operation is done. So 20 bar 4 is 5. Then within bracket, when a bracket is given, we want to perform the operation within a bracket first. So 3 minus 1 is performed. The value is 2. So in the second statement, star has the higher preference. So 3 star 2 is equal to 6. 5 minus 5 plus 6 is an expression. Here minus and plus are there. Both has the equal precedence. So we are traversing from left to right. 5 minus 5 is 0. 0 plus 6 is 6. The value is 6. So in the subsequent sections, we will see about the input and output functions, looping statements and etc. Thank you.